9.4, we're going to talk about parametric equations. It sounds a lot scarier than it actually is. The topic itself is new. This is one topic that we haven't done in Algebra 2, so it is new stuff, but the math behind it, you guys know what to do. We're going to be graphing, we're going to do some algebra stuff. Once you see it, you're going to be like, oh wait, this is actually not bad. So up to this point, you've been representing a graph by a single equation involving two variables such as x and y. In this section, you'll study situations in which it's useful to introduce a third variable to represent a curve in the plane. So the third variable is going to be time. We're going to talk about t, which will be our time. So we'll have x, y, and t. So on the next page, we have an example. It gives us the rectangular equation. This is what we're used to. This is just our x and y in the equation. But we're going to talk about parametric equations. So we're going to have two equations. We'll have an x equals and a y equals, and then we'll have t in our equations. So our graph will be with respect to time. One of the major differences in our graphs with this section versus just a normal graph is that our graph is going to have orientation. We'll have this arrow here. So you're going to show like where you start and where you end in your graph. So you'll have to include the arrows. So our graph tells us where the object has been, but it does not tell us when the object was at that given x and y point on the path. To determine this time, you can introduce a third variable, which is t, which we call the parameter. It's possible to write both x and y as functions of t to obtain the parametric equation. So like I said before, we'll have an x equals and a y equals and a t in both of those equations. These are going to be our parametric equations. So we're going to talk about graphing our plane curves. So one way to sketch a curve represented by a pair of parametric equations is to plot the points in the xy plane. Each set of coordinates x and y is determined from a value chosen for the parameter t. So we pick what t we want to plug in. By plotting the resulting points in order, so super important is that they go in order of increasing values of t. You trace the curve in a specific direction. The specific direction is called the orientation. So that orientation is going to include our arrows. So not only are we going to have points on our graph, but the points are going to go in a specific order, and we're going to show that order using arrows. So we want to sketch the curve given by the parametric equations. So when we graph here, I'm going to make a chart. I'm going to make a little table to help us plug in values. So we're going to plug in values of t. Now it gives us what values of t we should stick in between. So it says we want to plug in values of t from -2 to 3. So we're going to follow this here. We're going to plug it into our x and figure out what x equals. Then we're going to plug it into our y and figure out what y equals. And then that'll give us points x, comma, y. Once we have our points, we'll plug them into our graph and graph it. So for t, we want to start with the smaller number and then we just increase from there. So I'm going to start by plugging in -2, then -1, 0, 1, 2, and 3. So we just plug in all the numbers from -2 to 3. Now with the WebAssign, the graphing questions are going to be multiple choice, but I need to see this chart with each question. You can't just say, oh, I just plotted the points in my head and did all the work in my head. No, I need to see the table and I need to see your points. I need to see your graph. You need to graph it.
That applies to every graphing question?
Every graphing question on this WebAssign. Yeah. So I need to see this table, and on the test coming up too, you're going to have to draw the table. So you need to see the table. I need to see your work. If you do not show your work, you will get a 0 for the homework. So I need to see your work. So let's start by plugging in -2. So we're plugging this into our t in our two equations here. So starting with my x equation, I'm going to plug it into the t here. So we have negative 2 squared minus 4. Negative 2 squared would be 4, and 4 minus 4 is 0. Perfect. Now let's plug it into our t in the y equation. So we have negative 2 over 2, which would simplify to what? Negative 1. So our point here would be 0, comma, negative 1. I'm going to save plotting all my points for the end because that'll help me just stay in order. So next I'm going to plug in negative 1. Negative 1 squared would be 1, and 1 minus 4, negative 3. So we have negative 1 over 2 would just be negative 1/2. So our next point would be negative 3, comma, negative 1/2. Then we can plug in 0. 0 squared minus 4 would just be 0 minus 4, which is what? Negative 4. And then 0 over 2 would simplify to what? 0. So our next point would be negative 4, comma, 0. Then we can plug in 1. So 1 squared minus 4 would be 1 minus 4. What's 1 minus 4? Negative 3. And then we have 1 over 2, which would just be 1/2. So our next point would be negative 3, comma, 1/2. Then we can plug in 2. 2 squared would be 4. So 4 minus 4 is 0. And then 2 over 2 would simplify to what? 1. So our next point would be 0, comma, 1. And then lastly, let's plug in 3. 3 squared would be, and 9 minus 4, 5. And then when we plug it in here, we have 3 over 2. Now when we graph, it might help to change the fraction to be either a mixed number or a decimal. What would the decimal version of 3 over 2 be? 1.5. 1.5 or 1.5. This will just help us graph it. So we have 5, comma, 1.5. All right, so now let's go to our graph. We're going to plot all of these points. So starting with the first one, it's super important that we go in order. So I'm going to start with my orange point here. We stay at 0, go down to negative 1. Then I move on to the pink point, so I'm going to go to the left to negative 3, down 1/2. Then my teal point, we go to the left 4 to negative 4, stay at 0. The black point here, we go to the left to negative 3, up 1/2. And then the green point, we stay at 0, go up 1. And then lastly, our purple point, we go to the right 5 and up 1.5. Now we want to connect all of these points in order that we graphed them. So I started at the orange point, I went to the pink one, then the teal. I'm going to show a curve. You don't want your graph to have a sharp point. You got to show that curve. And then we went to the black point, to the green one, and then to the purple. So next we got to draw the orientation. The orientation is the arrows. So I started from the orange, I went to the pink, so I'm going to put an arrow there. From the pink, I went to the teal, so I got to put an arrow there. From the teal, we went to the black, so we got to put an arrow there. Black to the green, and then green to the purple. I'm going to start with my chart. So we're going to have our values of t that we'll plug in. We'll have our x equals and y equals, and then we'll have our point x comma y. So we're going to plug in these values for our t. So starting with the smallest one, we have negative 1. Then just plug in until you get to the largest number. Stick with the whole numbers, but if your starting and stopping point happen to be a fraction, then you just have to plug in that fraction. But from negative 1 to 3/2, we want to plug in all the whole numbers in between. So we have negative 1, 0, 1, and then 3/2. So first thing we want to do is plug it into our x equals equation, we're going to plug it into the t. So we have 4 times negative 1 squared minus 4. Negative 1 squared would be 1. 1 times 4 is 4. 4 minus 4 would be 0. Perfect. And then when we plug it into our y equation, it's just t. So we don't even have to do any math there. Our y equals would just be whatever t is, so negative 1. So our first point is going to be 0, negative 1. Next point, we're going to plug in 0. So 4 times 0 squared minus 4. 0 squared is 0 times 4 would be 0. 0 minus 4, negative 4. And then we plug it into our other equation, we get 0. So here we have negative 4, 0. Next, when we plug in 1, we have 4 times 1 squared minus 4. 1 squared would be 1 times 4 is 4. 4 minus 4 is 0. And then 1 would just be our y. So we have 0, 1 for our next point. And then let's plug in 3 halves. So 4 times 3 over 2 squared minus 4. What would 3 over 2 squared be? Awesome. You got to square the 3 and square the 2. So we have 4 times 9 over 4 minus 4. The 4's cancel here, so that would just be 9 minus 4. What's 9 minus 4? 5. And then our y value would just be 3 over 2. So 5, what's the decimal version of 3 over 2? 1.5, or you could call it 1.5. Just make it a mixed number to make it better for you to graph, more helpful to help you graph. All right, let's plot these points. So I'm going to draw my graph here. All right, so starting with the orange point, super important that you go in order. So we stay at 0, go down to negative 1. Then our pink point came next. We're going to go to the left to negative 4, stay at 0. Then with our teal point, we stay at 0, go up 1. And then with the purple point, we go to the right 5 and up 1.5. So now I started at my orange point. I'm going to connect the dots. I went to the pink one. We got to show a curve because it can't have a sharp turn in your graph. Then to the teal point and then to the purple. We have to show the orientation. The orientation is the arrows. So I went from the orange to the pink, pink to the teal, teal to the purple. So super important for your web assign that you show your work. I got to see this table. If you do not include the table and you just pick your answer, you're not going to get any credit for the homework. I need to see your work. All right, next part, we're going to be eliminating the parameter. So the parameter is our t value. We're going to be getting rid of it. So we're going to be eliminating the parameter. So here it shows us the steps that we can do to eliminate the parameter. It says many curves that are represented by a set of parametric equations have graphs that can also be represented by rectangular equations in x and y. The process of finding the rectangular equation is called eliminating the parameter. So we're going to start with our two parametric equations. We'll have an x equals and a y equals. You want to solve for t in one of the equations. It doesn't matter which one. Look at your x equals and your y equals. Figure out which one would be easier to get t all by itself. So here, they solved for t in the y equals equation. They just multiplied both sides by 2 to move the 1/2 to the other side. So they got t equals 2y. Once you solve for t in one of the equations, you're going to use substitution. Plug it in to the other equation. So substitute it into the t in the other equation, and then you just simplify to get your rectangular equation. So some of these questions are going to require more simplifying than others. Here they just squared the parentheses, so they had to square the 2 and square the y. And that was all they had to do to simplify, but some of the ones that we're going to practice will require a couple more steps to simplify. But you just want to simplify. You can keep it as either x equals or y equals, depending on what you solved for in the beginning. Your answer will look a little bit different if you have x equals or y equals. So just keep that in mind. If you solved for x, but your friend solved for y in the beginning, your answers might look a little bit different, but WebAssign will take it either way. So looking at example 3 on the next page, we're going to cross these questions out. I'm going to make up new ones here. So ignore the x and the y there. I'm going to make some new equations. So we have x equals 4 minus 2t and y equals 3 plus 6t. So now in one of these equations, we want to solve for t. I think the first one might be a little bit easier to solve for t just because the numbers are a little bit smaller, but you could have done it with the y equals equation too. So I'm just going to work with the x equals. So I want to get t all by itself. So I'm going to subtract 4, move it to the other side. So x minus 4 is equal to negative 2t. What could we do next? Divide by negative 2. So we get t equals, I'm going to simplify here. So I'm going to split this up into x over negative 2 and negative 4 over negative 2. So that would be negative 1/2 x. And then negative 4 divided by negative 2 would simplify to just positive 2. If you wanted to leave it as a fraction, you can. So different ways of simplifying here. You could have left it as a fraction. That would have been fine. Next, I'm going to take what t is equal to, and I'm going to substitute it into the t in my other equation. So since I found what t was equal to in my x equation, I'm now going to substitute it into the y equation. So we have y equals 3 plus 6 times 1/2 x plus 2. What should we do next? Distribute the 6. Perfect. So we have y equals 3. 6 times negative 1/2 would be negative 3x. And then 6 times 2 would be 12. What else should we do to simplify?
Combine like terms.
Combine like terms. So we have y equals negative 3x plus 15. So that would be our answer. Now again, if you were to solve for the other one, you would have gotten x equals. It would look a little bit different, but still be correct if you did the math right. The most important thing is that you eliminate the parameter. Notice how in our equation here, we have no t's anymore. We eliminated the parameter. So again, with example 4, I'm going to write new questions here. So again, we are eliminating the parameter with two different questions. Let's say we have x equals negative 2t minus 3 and y equals 2t squared plus 2t minus 5 over 2. Which one do you think would be easier to get it to be t equals?
X.
The x. Because in the y equation, we have t squared and t, so we wouldn't even be able to combine those together. So we have to work with the x equation first. So I'm going to solve for t. What should we do first? Add 3, move it to the other side. So x plus 3 equals negative 2t. Divide everything by negative 2. So t is equal to x plus 3 over negative 2. Now here, if I were to split it up into two different numbers, if I put x over negative 2 and 3 over negative 2, it just leaves us with fractions. So I'm just going to leave it all together as one fraction. Again, different ways that you can simplify. You'll all end up with the same answer. I'm going to take this now that I got t all by itself, and I'm going to plug it into the t's in my y equation. So we have two t's there, so we got to plug it into both of them. So we have y equals 2 times x plus 3 over negative 2 squared plus 2 times x plus 3 over negative 2 minus 5 over 2. Now we have some simplifying to do. What should we do first to simplify here?
Squared.
The squared. Let's do this part first. I'm going to do it on the side over here because when we square it, we have to square the numerator and square the denominator. But when I square that x plus 3 squared, that's like saying x plus 3 times x plus 3, which we have to FOIL. So we get x squared plus 3x plus 3x plus 9. So that would be x squared plus 6x plus 9. So we have 2 times x squared plus 6x plus 9 over negative 2 squared would be what? 4. And then plus, here in my second part, the 2's will cancel, but I still have that negative that I'm dividing by. So this would actually turn into a minus x and minus 3 and minus 5 over 2. I can also simplify the 2 and the 4 here, but I'm still left with 2 in my denominator. But because I have a lot of like terms here, I'm going to split them all up separate. So I've got y equals, I'm going to call it x squared over 2 plus 6x over 2 plus 9 over 2. And then minus, just because everything has a denominator of 2, I'm going to give everything a common denominator. I'm going to make these have 2 in my denominator just so it's easier for me to combine like terms. There's many different ways that you can simplify this. So if you're doing something else to simplify, you're not doing it wrong. There's just different ways that you can work with this. I am going to give everything a common denominator. So I'm going to make this minus 2x over 2 and then minus 6 over 2 and minus 5 over 2. Just so everything has a common denominator so I can combine all my like terms from here. So I'm going to start with x squared over 2, then move on to my x's. What's 6x over 2 minus 2x over 2? Awesome. So this would be plus 4x over 2. And then we have 9 over 2 minus 6 over 2 minus 5 over 2. 9 minus 6 would be 3. And 3 minus 5, negative 2 over 2. So we could simplify just a little bit more. First one doesn't simplify, so if you want to put it as 1/2 times x squared, you can, or just x squared over 2. What does 4x over 2 simplify to? 2x, perfect. And negative 2 over 2 simplifies to minus 1. So that would be our answer. So notice here we got rid of the t's. We eliminated the parameter. That is the main goal. So eliminate the parameter and just do the algebra part correctly. So you're just doing a lot of combining like terms, simplifying. Just make sure you're careful with your simplifying so you can simplify correctly.